Normal distribution is a probability distribution that summarizes the likelihood that a value will take one of two independent values under a given set of parameters. A binomial distribution has only two outcomes. The expected outcome is called a success, and any other outcome is a failure. The probability of a successful outcome is p, and the probability of a failure is 1 minus p, meaning q. In order to use binomial distribution, the case has to be a win-fail scenario, or in other words, have two possible outcomes. Also, it must be a mutually exclusive event. N stands for total events. P stands for probability of X happening once. Q stands for 1 minus P, the probability of X not happening. X stands for the number of times you want the event to happen.
Distributions, there's a lot of cases you can use this formula. You just have to have a situation or a problem that can fill these 4 points. In the first case, you throw a coin 3 times, and the x will be the number of tails that could show in those three tossing of the coin. And well, you arrange the numbers here, and then you substitute it in the formula, each one, and what you get, you add it, and that's the probability of the tail showing 0 times, 1 time, 2 times, or 3. In this other case, they are telling you that what's the probability of if you throw it 5 times to get 2 tails. So in the x right here, you can write 2 tails because that's the number of events you want to happen. And then you substitute everything in the formula, and that's what you get. In here, there's throw a coin 2 times and get 2 heads. In the other problems, you were searching for tails, and now you're looking for heads, and that's where this Q, it's important. And then, well, in here, you put in the x 0 because you want that the 2 times that the coin is tossed, that 2 heads show up, nor not 2 tails. So whatever.
Okay, so this is the first example of binomial distribution. Here you can find the formula to solve these problems. And the first example is, we throw a coin 3 times. What is the probability to get tails 1 time? So the first step is to find our variables. Which are variables? Our n, that is the total events. How much events do we have? 3 events, because we throw a coin 3 times. So our n is 3. Then our probability. Our probability to get tails is 0.5, or 1/2. So 0.5. Then what is the probability of not getting tails? So 1 minus p. And 1 minus p is 0.5. 1 minus 0.5, 0.5. Finally, our x is the number of tails. So number of tails, in this case, is 1, because we would like to know the probability to get tails 1 time. Okay, then continue with the formula. We have the probability of x being 1, because we would like to know, again, 1 time, is our n, 3 times c. As the formula says, c1, we toss a coin 3 times, and we'd like to know what is the probability to get tails 1 time. Then the probability of getting tails, 0.5, to the power of our x, that is 1, times again the probability of not getting tails, which is also 0.5, to the power of our n, 3, minus our x, minus 1. Simple as that. We input that in the calculator. We have 3, the special key c, 1, 0.5 to the power of 1, again parenthesis, times 0.5 to the power of 3 minus 1. 3/8. So we're right here. The probability of getting tails 1 time is 3/8, or in decimal form, 0.375. Different kind of example, but it's also binomial distribution. I just changed a little bit the context. So, okay, here we have the formula again. The first step, as I said before, is to find our variables. So here it says, The probability of winning a match for team A is 0.6. Find the probability of winning 3 matches out of 5. So here is the key, out of 5. So our total events are 5. Now, our probability of winning is 0.6, as the problem says. So 0.6 is our probability. So now, our Q, we find it with 1 minus P. So 1 minus 0.6 is 0.4. So our Q is 0.4. Finally, our X. Our X is winning 3 times. So our X is 3. Continuing with the formula, the probability of winning 3 matches out of 5. So our N, 5 matches. For C, how much times do we want to win? 3. So 3. Our probability of winning is 0.6 to the power of our X. Our X is 3. We would like to win 3 times. And our Q of not winning or losing is 0.4. So 0.4 to the power of our N minus the times we want to lose. So 5 minus 3. We input that in the calculator. So it's 5, C, 3, 0.6 to the power of 3, 0.4 to the power of 5 minus 3. That's, in decimal form, 0.3456. So 0.3456 is the probability of winning 3 out of 5 times.
Okay, so some of the most common real-life applications of binomial distribution are found in the probability theory, and a very large part of these can be found on the country's economies, given the fact that most economies depend on probabilistic analysis that are very useful to determine the chances of profit and loss, which is a great deal with developing economies in every country. The binomial distribution is also very used in higher maths and calculations, but moreover, this binomial theorem is used in forecast services, given the fact that finding out about the future weather is nearly impossible without binomial distribution. The disaster forecast is also very dependable among these binomial. And also, another very common application for this theorem is used in architecture, given the fact that it's needed to give shape and determine the areas of infrastructure in a building. And it's very useful to find the amount of material to be used in that and to help the estimation of how much space and material and expenditure in total will be needed to build a building. So yeah, these are some of the most common real-life applications that we can see on our daily lives.